Can anybody relate to this? How I see math word problems. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. That makes absolutely no sense, right? My experience has been that a lot of students coming into Chem 3A feel that way about math word problems. So the bad news is that there are a lot of math word problems in Chem 3A. The good news is I can help you learn to make sense of them, okay? You're going to have to work at it, though, and you're going to have to ask me questions, but I can help you. Most students, if I give you an equation, you can solve the equation, but if I give you the problem in words, the difficulty you have is getting from the words to the math equation. So we have to have some critical thinking steps getting from the words to the mathematical equation. Some of you in the past may have gotten through classes by just memorizing how to do particular problems. Well, that works for those particular problems. The difficulty is that there's no simple formula that's going to apply to everything. There are so many different problems that it would take you a really long time to memorize for each of them. But there are some problem-solving strategies. Many problems really end up just being a matter of converting units from one to another, like taking the distance from Reedley to Fresno in miles and converting it to inches. There are other types of problems that do require the use of particular equations, and we're going to look at both of those. It's important to recognize that units behave a lot like variables, A's and B's and X's and Y's. You can multiply, divide, and cancel them like any other algebraic variable. The technique of using units as our guide is called dimensional analysis. Some books call it unit analysis, which I prefer, but your book calls it dimensional analysis. Unit analysis. This is solving a problem by looking at the units. I learned this as a junior in high school in physics class. And after many years of life experience, I can say that was probably the most valuable thing I learned in high school, was unit analysis. So, important things to remember. Always write every number with its associated unit. Remember that spaceship that went down because of units. We don't want to have that happen. Always include units in your calculations, and don't let those units magically appear and disappear. Okay? So some wishful thinking happens with units. You can't just slap a unit on it because you think that's what it should be. Treat them like variables, and they're going to follow the rules of math. So for most conversion problems, we've got a number, a quantity with one unit, and we need to convert it to another unit. This is like taking a piece of paper that is 1 foot long and figuring out how many inches it is. It's the same piece of paper. We're just describing it with a different unit. So the unit and the number are different, but it represents the same quantity. So the general form is that we start with the information that's given. We're going to multiply by one or more conversion factors, and then we're going to get the information that we're seeking. Excuse me. So we have a given unit. We multiply by a conversion factor. These are going to take this form, the desired unit over the given unit. And that will give us the desired unit because that given unit is going to cancel out. So that's the big idea. Where do these conversion factors come from? Well, sometimes we need to look them up in a table. Things like 1 kilometer equals 0.6214 miles. I don't expect you to memorize that. I don't remember that one. Or the relationship between a meter and inches or a meter and yards. There's one on here that I do want you to memorize just because we use it so much. 1 inch equals 2.54 centimeters. Here are some conversion factors, equivalences for mass, and here are some for volume. So they can be found in a table, or we may use the metric prefixes to create them. And that's something that you do need to know how to do. So let's say that we needed the relationship between centimeters and meters. So 1 centimeter equals how many meters? Well, what does centi represent? 10 to the what? 10 to the minus 2. 10 to the minus 2. What if we had 1 microgram and we needed to know how many grams that was? What does micro mean? 10 to the negative 6. This is why I made you memorize those things. So just by memorizing metric prefixes, we can generate a whole bunch of different conversion factors within the metric system. When you're going between the metric system and the English system, you're going to need a conversion table. Okay? On an exam, I will give you those odd conversions that you need. But I do want you to memorize this one, the inch centimeter one, because that one comes up so much. So let's construct a couple of conversion factors. Let's relate feet and inches. I almost said finches and eats. Yeah. Okay, feet and inches. So the conversion factor is 1 unit over the other. And so there's a couple different ways to think about it. Let's just start out this way. What is the relationship between feet and inches? 12 inches is a foot. So 12 inches equals 1 foot. Well, let's do a little math on this. In math, if you have an equality and you do the same thing to both sides, it's still equal. What if I divide both sides by 12 inches? Is it still equal? Yeah, I did the same thing to both sides. It's like a teeter-totter. It's all balanced, and if I put the same size rock on each side, it's still balanced. What's 12 divided by 12? 1. We'd say those cancel out. What's inch divided by inch? 1. Anything divided by itself is 1. Inch divided by inch is 1. And so this equals 1. 1 foot over 12 inches is equal to 1. What? How do you do that? It's magic. No, it isn't. What if I flip that upside down? It's 1, right? If I flip it upside down, it's still 1. I could have 12 inches over 1 foot, and that's also equal to 1. Is 12 inches the same size, the same length as 1 foot? Yeah. They are 2 different names for the same quantity. They are equal. And that's why this ratio is equal to 1. All conversion factors are equal to 1. And that's why when we multiply by them, it doesn't change the value of what we're measuring. Let's do inches and centimeters. 1 inch is how many centimeters? 2.54. That conversion factor is exact, by the way. Most of the ones between the metric and the English system are not exact, but this one is exact. They actually redefined the inch to be exactly 2.54 centimeters. So these 2 quantities are equal to each other. I can make a conversion factor just by putting one of them on top and the other one on the bottom. So I can do it like that, or I can put the centimeters on top and the inches on the bottom. What you have to be careful with is that you keep the 2.54 with centimeters, because it's not true that 1 centimeter equals 2.54 inches. That's not true. Any questions yet? So when we're solving problems, make sure that you end up with the final unit that you were trying to end up with. Look at the magnitude, the number, the size of the thing, and ask yourself, does it make sense? Is that reasonable? If I converted 26 miles to inches and got 0.005 inches, would that be reasonable? No, it wouldn't. That would tell me to go back and look at my work because I did something wrong. And remember that conversion factors can always be inverted. You can turn them upside down because they're equal to 1 and the inverse of 1 is just 1. So, we talk about a solution map. A solution map is just a visual outline that shows how we're going to solve a problem. Any of you guys ever watched Dora the Explorer? Yeah, you're maybe a little past that generation, but maybe you had younger siblings that watched it. So Dora was always trying to get somewhere, and she didn't know how to get there, right? She needs to get to the snowy mountains. Well, who do we call when we don't know which way to go? The map. And the map would come and say, well, to get to the snowy mountains, first you have to go over the bridge and through the scary woods, and then you get to the snowy mountains, right? And then they would chant that several times so that they could remember it. That's what we're going to do when we solve these problems. First, we need to know where we are, and then we need to know where we're trying to go, and then we'll figure out how to get there. Now, for some of you, this is going to be easy. And so these steps that I'm going through, you're like, yeah, whatever. That's fine. You'll be good on your own. The rest of you, which is probably most of you, at the beginning at least, you're going to want to write that map down. Because when you start throwing numbers and units around, you're going to forget that you were going over the bridge and through the scary woods to get to the snowy mountains. So write it down so you don't get lost. Okay? The solution map focuses on the units. So our map might be, I've got centimeters, and I'm going to convert those to inches, and the inches I'm going to convert to feet. And so that will be our map. So we'll start with some really simple ones, not as complicated as Dora does with the 3 things. So going from inches to centimeters, I'm starting with inches, I'm going to centimeters, and I can do that in 1 step. Here's the relationship between centimeters and inches. If I had centimeters and wanted inches, then I'd be starting with centimeters and going to inches. So, identify the starting point, the given information. So you read through all the words. Read it out loud if you need to. Read through all the words first, and then go back and say, what unit am I starting with? And then identify what you're trying to find. Write those down. And then figure out how to get from where you are to where you want to be. So solution map can help you write it out. And so what we're doing is we've got our given quantity, our solution map, which may just be a direct 1-step conversion, or it might have multiple steps, and this is what we're trying to find. We're going to sort. So we look at the information. Sometimes there's a whole bunch of numbers in there. We have to sort them. Decide, well, what's the starting one? What's the ending one? What might be conversion factors? Sometimes they throw in extra numbers that you don't actually need to use. Then we strategize. That's coming up with the solution map. Solving. That's where you actually do the math. We need to always practice with our significant figures. And we're going to cancel out units as needed. And then checking is the very important last step. Does it make sense? Are the units correct? Did I do the significant figures correctly? Let's do some examples. Okay, so we're going to start out with word problems that have very few words. Convert 56.0 centimeters to inches. I read the problem. What unit am I starting with? Centimeters. I'm starting with centimeters, and what's the question asking me to find? Inches. So I've got my start and I've got my find. Now I need to strategize. In order to convert from centimeters to inches, I need to know the relationship between them. Okay, we've talked about this one already. If you don't remember at this point, you go look it up. And you look it up in the table, and it says 1 inch equals 2.54 centimeters. If I can find a relationship like that, or make one using metric prefixes, then I can do this in one step. My path is very simple. I'm going to go from centimeters to inches. So now I'm ready to actually set things up. I'm going to take this number that I'm starting with its starting units, 56.0 centimeters. I'm going to look at my path here and see I have one arrow. That means I need one conversion factor. So times, and I'm going to have one factor. And that's going to equal my answer. This path tells me what units go in the numerator. So I start with centimeters, and then inches is in the numerator. So I'm going to write inch up here. That's the path. Centimeters to inches, that's where I want it to be. Well, I need to make the centimeter go away. So I want to divide by centimeters. So I'm going to put centimeter down here. Because centimeter divided by centimeter is 1, and we say those cancel out. So that's how I make that unit disappear. Unit analysis or dimensional analysis, we let the units go first. We figure out how the units are going to work out, and then we put the numbers in. So now that I've got my units working out, I'm going to go back to this relationship and say, well, how many inches is equal to how many centimeters? Well, it's 1 inch to 2.54 centimeters. So mathematically what I need to do is take 56 and divide by 2.54. And I'm going to write down what my calculator says. 2.2047241. And what unit is not crossed off? Inch. Does it make sense? Well, 56 centimeters, you might have, it's like, well, I don't know. Well, a meter is 100 centimeters. So this is roughly half of a meter, half of a yard, 22 inches. Yeah, when these go wrong, they go very badly wrong. Because what happens is you multiply by 2.54 instead of dividing. Yes?
So if it was from inches to centimeters, would we do it, just switch it to the base?
Yeah. If we were going the other way, if we were going from inches to centimeters, then this conversion factor would be flipped upside down. Yep. And then the other thing we have to do is we have to look at significant figures. This is an exact conversion. Anytime you have an exact relationship, you can just ignore sig figs, because those will not limit your sig figs. So then we end up just looking at our starting number. How many significant figures in that one? I heard 2, 3. There's a trailing 0 there, but there's a decimal point. Our starting number has 3 significant figures, so our answer should have 3 significant figures, and we're going to report this as 22.0 inches. I prefer the abbreviation because you don't have to worry about singular plural business. Any questions? I strongly urge you to show your work. Okay, minimum showing your work would be this stuff right here in the blue box. That should be the minimum that you write down. Now, some of you will want to write down the stuff at the top, maybe write even more stuff down, but the very minimum is down here. When you write everything out and you find out later that you've made a mistake, you can go back and see what you did and correct the mistake and learn from the mistake. If you just write down an answer and it's wrong, you have to start all over, okay? So I really don't recommend that. Let's do another example. 5678, 5,678 meters to kilometers. Why was 6 afraid of 7? Because 7, 8, 9. Okay, so again, we don't have a lot of words here. There's 2 units. Okay, so some of you might be saying, okay, well, there's 2 units. One's where I'm starting, one's where I'm going to. I'm not sure which is which. Okay, that's a good question. The one that has the number is where you're starting, and the one without a number is where you're going. So we're starting with meters, and we're going to kilometers or kilometers. That's our beginning and our ending. Now we have to figure out how to get there. Well, the difference between these 2 units, come on, pointer, is just a prefix. So I can do this in one step because I know the meaning of these prefixes. 1 meter equals 1 kilometer. Well, that can't be true. These are not the same, right? What does kilo mean? 1,000, or 10 to the 3. So this and this are different names for the same thing. Okay, one of my sons always goes by his nickname. His given name is Thomas. So Thomas Kawagoe. We never call him that. We call him Tommy. Thomas Kawagoe or Tommy Kawagoe. Nobody calls him Tommy Thomas Kawagoe or Thomas Tommy Kawagoe. That's just absolutely ridiculous. There are different ways to set up these metric conversions. I would encourage you, though, to just follow my way because it works and there aren't any exceptions. So you memorize what the prefix means. Kilo means 10 to the 3, and the number and the prefix never go together. Never. Okay, so we've got our relationship there. Now we can actually write the equation out. We've got 5, 6, 7, 8 meters. I'm going to look at my path that I made, my map. 1 arrow, 1 conversion factor. So I've got that all figured out, and now I go back and I look at what are these units? Meter to kilometer. And I always imagine Dora chanting. Bridge, scary forest. So here's meter, and then on the top I write kilometer. This unit I need to go away. I need it to go away. So I'm going to divide by that over here. So these guys are going to cancel out. Any questions? Now I need to make the top of this equal the bottom. And so that's where I get 1 kilometer and 1 times 10 to the 3rd meters. So 1 kilometer, 1 times 10 to the 3rd meters. If you just write 10 to the 3rd meters, that's fine too. But then you might wonder, well, how am I supposed to put that into my calculator? So our units are all okay. Now we need to use our calculator. So this 1 times 10 to the part, that's the EE button or the EXP button on your calculator. So to do this, we've got 5, 6, 7, 8 times 1. If you want to multiply by 1 in the top because it makes you feel better, go right ahead. It's not going to change anything. Divided by 1, EE 3. And so I end up with 5.678 kilometers. There's no remembering which way do I move the decimal point. You follow the steps and it always works out. It's a beautiful, beautiful thing. What about significant figures? There were 4 in our starting number. Anytime you have a relationship between metric units, that's an exact conversion, because 1 kilometer is exactly 1,000 meters. We defined it that way. We set it up that way. So exact conversion, we just don't even have to think about it. We started with 4, we end with 4, and so this one ends up being just fine the way it is. Questions?